Hi everyone, and welcome to this, my VCAA 2023 sample exam for the General Maths Paper 2 video. Whew. My name is Darren from Maths Guru. Thanks very much for joining me. Hopefully you're going to find this video walkthrough really helpful. Before I get started, if you can do me a massive favor and subscribe to my YouTube channel, that will be massive. Why? Nobody watches maths videos. And believe it or not, when I get more than 3 subscribers in a day, I actually do a happy dance, which really is quite embarrassing, and run around my apartment. That's weird because my dog thinks I've lost the plot. And bearing in mind not too many days to get 3 subscribers, you can tell that my life is very sad and tragic. So if you can do that, that would be great. Now I'm going to go through this. I am 99.95% sure that the answers are correct. Do you see what I did there? It was an ATA joke. They really don't get any better. And so if there are any errata, I'll put them in the description, either on mathsguru.com or on YouTube for you to have a look at. All right, there's only one question which I think is a bit dodgy. I don't really like the wording of it, but sometimes those things happen. Now, a lot of these questions you're going to see are pretty similar because VCAA have not really created a brand new sample exam. They've just taken questions from other papers. But there are things in here on Leslie matrices and what have you, which will be relatively new. So shall we get going? I should Coco. Now, before I get into this, again, just remember, please, that I am going to use the TI Inspire. I'm sorry, ClassPad users, my license has expired, and I really don't know how to get another one. So the TI Inspire's functionality is pretty similar. Hopefully you'll bear with me. Okay, now, again, I'm not endorsed by VCAA. These are just my suggestions at what I think the answers are going to be. Question number 1, 4 marks. The table below displays the average sleep time in hours for a sample of 19 types of mammals. There we go. What does the question actually say? Which of these 2 variable types, type of mammal or average sleep, is a nominal variable? Now, I remember nominal as having no order, which means it's categorical. Average sleep time is numerical. So in this situation, I'm just going to put type of mammal. Now, my handwriting, M-A-M-M-A-L, is not going to be fantastic on this because I'm writing on electricity. I really need to get one of those nibs. I keep seeing them on YouTube about, oh, get the nibs for the pens. It feels like writing on paper. Determine the mean and the standard deviation of the variable average sleep. Now, I tend to highlight the things that I need to know. Average sleep. Now, obviously, in an exam, you'll be fine. There we go. I'm going to do average sleep. How am I going to do this? I can't do it in any other way other than to use my calculator. So in this situation, I'm going to fire up my calculator. He says, I'm bringing it up onto my screen. Bear with me. Hold the line. Thank you very much. Where's my mouse gone? Come back. Right. So I'm going to do a list and spreadsheet. I always do a title here. So I'm going to type sleep. He says, trying to see what's going to go on. And there we go. So 14.5, 13.8. 13.2, 13.2, he says. Now, interestingly, I'm watching all of this, trying to avoid all of the stuff on my desk. 13, 12.5, 12. 12.5, what have I got here? 12, 10.8, 9.8, 9.8. Now, see what's going on here? 9.8, 9.8. Now, imagine this was in an exam, and I'm all fingers and thumbs at the moment, and I'm making mistakes. That's not going to go down too well, because I'm going to end up making silly mistakes. 3.8, 3.1, 2.9, and 2.6. I think those are the 19 data items that I needed. Yeah, now again, what I normally do then is I check that I've got 19 data items, and I just do a cursory sort of scroll up just to make sure I haven't done anything wrong there by putting wrong values, because previously I did. Now, a piece of advice, when you do these things, don't put your fingers, don't do the numbers like this with using your fingers. This was a good piece of advice I got from a colleague of mine today, because the calculators aren't built like mobile phones. They're not responsive, so you should always do it with one finger. What I tend to do is rub my finger down the numbers just to make sure that, I'm following them as I would. Now, how are we going to do this? Rightio, we're going to go menu, if you will, please. I'm going to go statistics, stat calculations. My calculator's oversensitive on my screen. Stat calculations, 1 variable statistics. Yes, please. What? I've got to tell it that I want sleep. And there we go. And obviously in this situation, I've just got to try and choose the right values that I come out there. And so X bar is my mean. So I'm going to write in there, what does it want? My to 1 decimal place, which is going to be 9.2. He says writing in highlighter. 9.2, and my standard deviation, which is SX, and I won't tell you how I remember that one because it's mildly inappropriate. Moving on. What is it? 1 decimal place is going to be 4.2 hours. Now, again, it's really important here that you actually do these to the correct number of decimal places. Why? because VCAA will knock your marks off. It used to be that they knocked you 1 mark off for every single for the paper, but now sadly not. They're going to knock you 1 mark off for every single question. You don't really want to get into that in any way, shape or form. So let's turn that off for a moment. The average sleep time for a human is 8 hours. What percentage of this sample of mammals has an average sleep time that is less the average sleep time, so less than 8 hours? So I'm going to go back to my table and I'm going to highlight all the values that are less than 8 hours. Now the nice thing here is it was actually in numerical order. So we've got 1, 2, 3, 4, 5, 6. So I'm now going to do 6. And I'm going to divide that by how many were there? There were 19. And because it wants a percentage, I'm going to do that like that. Again, may as well leave my calculator up for this one here. I'm going to go Control plus, and let's add a calculator, and let's do 6 divided by 19, gives me that, times it by 100, and gives me 31 point blah, 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 blah. What accuracy do they want it near to 1 decimal place? So 31.6 percent, 31.6%. Ka-ching! Thank you very much for checking that's what I got earlier. It is. The sample is increased in size by adding in the average sleep time of a little brown bat. Its average sleep time is 19.9 hours. By how many hours will the range for the average sleep time increase? Now, 19.9 hours. I'm going to go back to my data. And if I look here, 19.9 would actually put it at the very, very top. So it's going to replace that 14.5. So, it's going to be bigger by how many? Well, actually, the trick to this question was to do 19.9 minus, so 19.9 minus 14.5, because this 14.5 used to be my highest value, and now it's just been increased by, well, whatever that difference would be. When I did it earlier, silly me, and again, it's not wrong, I did, well, let's work out the range for that. So I did 14.5 minus 2.6, and then I did 19.5 minus 2.6, and then subtracted them again. So if we put into my calculator, please, what did I want? 19.9 minus 14.5, he said, gives me 5.4. So there we go. So we would say 5. He says again, 5.4 hours. Right, job done. So there we go. So that was nice. I like that one. Question number 1. The 5-number summary below was determined from the sleep time in hours of a sample of 59 types of mammals. Show with calculations. Again, so important that you do this with calculations. That a box plot constructed from this 5-number summary will not include outliers. Right, so what is an outlier? Well, the first thing I know is that it's Q3 plus 1.5 times the IQR, and it's Q1 minus 1.5 times the IQR. So what I'm going to do is I'm going to say, well, therefore, my upper fence. Now, I would suggest here that you write upper fence. So my upper fence, let's do that now, is going to be Q3, which is my third quartile, which is 13.5, plus 1.5 times my IQR. What's my IQR? Well, basically, it is the third quartile minus my first quartile. So 13.5 minus 8. Now, I want to put that into my calculator. He says, what did I get? 11 point... nope, let's just turn over the page. Bear with me. So when I did that and put it into my calculator, I get 21.75. My lower fence is going to be 8.0 minus 1.5 lots of 13.5 minus 8, which is my IQR. And again, I put that into my calculator. I got minus 0.25. Now, a lot of people would actually leave the answers there. And I believe that VCAA are quite strict on this. And they'll say that doesn't pay out the answer. You have to write a qualifying statement. So, therefore, as 2.5 is greater than minus 0.25, and 20 is less than 21.75, there are no outliers. Now you're going to say, what does that mean? Well, again, you've got to show, because our outliers is anything that is greater than 20 and smaller than 2.5. Try that one again. So our biggest data item was 20, our smallest data item was 2.5, and anything that's bigger than 21.75 is an outlier. Well, 20 isn't bigger than that, and likewise, anything smaller than minus 0.25 would be an outlier, and 2.5 isn't. So you have to write that qualifying statement. Construct the box plot below. Now, please, munchkins, would you use a ruler? All right, use a ruler. So what do we got? We got our minimum at 2.5, and it's really important to make sure we get the scale. So there's my vertical line between 2.5. My maximum is at 20. He says, hoping that my eyesight is doing me good. My first quartile is 8, so there is 8. So I'm going to do a vertical line. Now, obviously, don't color in. I'm only doing this because I'm on my iPad at the moment. 13.5, I think, is here. Where's the other one? 10.5. 10.5 is here. And then I'm just going to connect those together with straight lines. And there we go. That should be enough for your 1 mark. But again, use a pencil and a ruler. Now, obviously, for a pencil, it has to be quite dark, because if it rubs out in the post, then you've got no marks, all right? So a lot of people turn around and draw it properly first and then say, okay, I'm going to go over it in pen a little bit later on just to make sure the examiners can see it. But again, rulers, rulers, rulers. All right, I think that was question 2. Question 3, the lifespan in years and gestation period in days for 19 types of mammal are displayed in the table. Cool. A least squares line that enables lifespan to be predicted from gestation period, right? Lifespan to be predicted. If it's being predicted from, it's the RV. So lifespan from gestation period. Right, what's the question? Name the explanatory variable of the equation of the least squares line. Yay. Well, in which case, because I've done that little diagram, I'm fairly sure that therefore I know the right answer is going to be gestation period. Have you subscribed to my YouTube channel? I know it's going to sound very needy, but if you could, that would be great. It really does mean the world to me. And it just lets me know that someone has watched this video. That little click, turn off notifications. If you never want to hear from me again, that's fine. But YouTube really do work on algorithms, and that little click from you really does mean a lot. Determine the equation of the least squares line in terms of the variables lifespan and gestation period. All right, we're going to go back to my calculator now. If you notice, I've still got my calculator fired up. What I tend to do is I actually delete that screen and I start a brand new one. Whenever I've got a question like this, I start a new one. Why? Because I don't want any variables left over from previous stuff, because it's just going to get in the way. All right, so just a piece of advice for you, rustling paper. All right, so what are we going to do? We're going to type this in. So I've got lifespan. So I'm going to put life. He says not able to see his keyboard. Where are you? Life and GEST. All right, so here we go. So now again, making sure I put the data in 3.2, 4.7, 7.6, 9, 9.8, 13.7, 14, 16.2, 17, 18, 20, 22.4. Keep checking, 22.4, 27, 28, 30, 39.3, 40, 41, and 46. Now again, checking I've got 19 data items. I do, quick scan up, make sure I haven't done anything really silly, like doing like 224, for example. Nope, that looks good. Gestation period, what have we got here? 19, 21, 68, 28, 52, 63, 60, 63, 150, 31, 151, 100, 180, 63, 281, 252, 365, 310, and 336. Good, that tends to work nicely. Thank you very much. What do I do now? Well, I tend to always do a graph. I tend to like doing it on the data and statistics. We know that in the bottom here, we had our gestation period. We know at the side there, we have our life expectancy. So there we go. Yeah, okay. And I go menu, analyze, regression, a plus bx. Now again, I tend to move this up just so I can see it a bit better. What I tend to say to people is this: remember that your calculator is a dumb piece of machinery. So although it says y equals there 7.5822, whatever it is, that's a lie. Yes, it's not actually y equals. It is what's on the y-axis. It's life and gestation period. And you'll notice here in the exam, they've basically given you a section that they've got to fill in all the stuff, because I think VCAA are testing more and more and more now. So I tended to write there. So lifespan is equal to, now it wanted it to round to 3 significant figures, and the number of VCAA students who can't round to 3 significant figures is actually quite terrifying. And VCAA love it, to be honest with you. They're like, yeah, let's keep doing this. Let's keep doing it. We'll do it to 3 significant figures. It'll knock people's marks off and we can stop them getting all the 50s. That sounds a bit of a silly way to run things, but actually that's pretty much what they're doing. Right, so 3 significant figures. Let's just scroll that up. Sorry that wasn't on screen a moment ago. Right, to 3 significant figures, 7.58 is my A, and they're going to do plus B, which is 0.101, so 0.101 times my gestation period. And there we go. There's my 2 marks for that. Again, 2 marks is important. Write down the value of the correlation coefficient rounded to 3 decimal places. Now, where on earth am I going to get my correlation coefficient? Well, 2 ways. I can go to menu, settings, and turn on diagnostics. Now the problem with that is it doesn't give me my value of r, it gives me my value of r squared. But there's a better way. Now when you actually clear down your screen, all right, and I'm going to do the calculator, when I shut that down and got rid of all the stuff previously, you'll notice that when I hit var, there's all these massive things all along here. Right, there's gestation, life, stat A, stat B, stat freak, reg, stat R squared. Well, basically, stat A is your value of A. So when you got y equals A plus BX, there's your A. Stat B is B, stat R. So if I click stat R and hit enter on my calculator, lo and behold, out comes the information for me. And it does it whether it's positive or negative. So I don't have to worry about any of that. What happens if I square root r squared and I don't get it as a negative value? It's all good. It's all done for me. So if I do that, what is my 3 decimal places? 0.904. So 0.904. Ka-ching. We're on to my next question. Question number 4. The scatter plot below shows the variable lifespan in years against the variable sleep time in hours for a sample of 19 mammals. On the assumption that the association between sleep time and lifespan is linear, a least squares line is fitted to the data with sleep time as the explanatory variable. Okay, so they basically just told me what the question is. The equation of this least squares line is given by that. Oh, I love equations of least squares lines. There's so much they can do with it, but it's fairly formulaic. The coefficient of determination is 0.416. Now, what is that? That is my value of r squared. I'm going to wonder if I'm going to come back to that later. Draw the graph of the least squares line on the scatter plot. So many of my students go, I don't know how to do this. I don't know how to do this. I'm just going to take a drink from my, oh, look, branded merchandise. Maths Guru mug. Great, I've been talking so long, my tea's gone cold. Ugh. Anyway. A lot of my students go, I don't know how to do this. I don't know how to do this. And it is one of the most common questions that I've seen over and over again. And the easiest way to do this is this line here, this least squares line is your predictor. But it's also a way to draw the gradient. It says if I have a sleep time, I times it by 1.9 and I take that away from 42 by 1 and that gives me a lifespan. This is another way of finding coordinates of my least squares line or yeah. So what I actually do now is I find the smallest value on my x-axis and the largest value on my x-axis and I put it in here. So let's see what we got there. So if I put my smallest value in, that's going to give me 0 as my sleep time. Put it into my equation here and I'm actually going to get out 42.1. Why? Because 42.1 minus 1.90 times 0 is just going to give me 42.1. Now what I'm going to do is put my highest value in. I'm going to put 18 as my sleep time in. Now let's use my calculator for that one because I can't do that one in my head. So I got 42.1 minus 1.9 times 18. Hit enter. What do I get? I get 7.9. 7.9. So I'm just going to turn over the page to make sure that I'm actually still following the answers that I did earlier. 7.9, right, and there we go. And now all I do is just plot those on my lines. You might, what do you mean plot them? So 0, 42.1 is going to be about here. Now, I can't see, but I'm fairly sure that's accurate. And then 18, 7.9 is going to be, roughly speaking, here. You've got to do it accurately on yours, and then using a ruler and a pencil, you just join those 2 points together. And VCAA obviously will be able to check that. My advice to you is when you're doing this, actually write the values of the coordinates somewhere on the piece of paper. Then they know that that's what you've actually been doing. All right, so there we go. So that's that one. Describe the linear association between lifespan and sleep time in terms of strength and direction. Well, the direction is nice and easy because it's sloping down. So we can automatically put in there negative. But how on earth can we do the strength? Well, we come back to my value of r squared. So in this situation, I'm going to square root the value of 0.416, that's going to give me 0.644. Now again, trick. My line is sloping down, so my value of r is actually minus 0.6449806, ... And that's where you dive for your summary book and you say, okay, I've got that table. I know that I can find the value of r in that table and it'll tell me whether it's strong, moderate, or weak. And as it turns out, you are going to end up with moderate because that value is going to be in the moderate section. There we go, moderate and negative. Now again, you don't need strong, sorry, what was the other one? You don't need linear. It's not asking for any more than that. It just wants strength and direction. Interpret the slope of the least squares line in terms of lifespan and sleep time. Now, interpret the slope. There is a standard textbook thing on here to be able to do. And I always write on average, comma, for every 1 hour increase in sleep time. Now, the point of it is you are always doing 1 unit increase on the EV. You always start the sentence with that one there. So because I was doing hours, it gave me the units is for every 1 hour increase. My understanding is if you don't put the units, you don't get the mark, right? VCAA are having to stop you getting marks. You've got to be precise with this. So on average, write that. It is average. For every 1 hour increase in sleep time, my lifespan, or the lifespan, not my lifespan, the lifespan, will decrease by 1.9 years. Right, the reason it's decreasing is because A, my gradient's negative, B, this value here is negative. All of this points to the fact it's negative. And again, you have to put that with the information in it, right? Now, interestingly, the next part of the question continues. Interpret the coefficient of determination, all right, in terms of lifespan and sleep time. These should be in your summary books as scaffolded sentences that you can effectively just change the numbers in. So we would know that 41.6%, you're going to go, whoa, where did that come from? Well, you take your value of r squared and you times it by 100, right? 41.6. So 41.6% of the variation in lifespan is explained by the variation in sleep time. Now, again, my handwriting is normally much better than this, but drop down, or don't put the exclamation mark. The examiners won't like that at all. All right, the lifespan of a mammal with a sleep time of 12 hours is 39.2 years. Show that when the least squares line is used to predict the lifespan of the mammal, the residual is 19.9 years. Now, let's just show that question. You've got to show sufficient working out. It's 2 marks. You've got to show enough in there. So I always write that residual, because this just reminds me. So the residual is equal to my actual minus my predicted. They've given me my actual, which I'll come back to in a moment. So I tend to say my predicted is given by, well, we know that from my equation that my lifespan, it says up there, so it's got it here, is 42.1 minus 1.9 times the sleep time. So I'm just going to substitute in my 12 hours, right? Because they've given me there that my sleep time is 12 hours. So my LS, my lifespan, my predicted lifespan is 42.1 minus 1.90 times 12. Now, I want to put that into my calculator. I get 19.3 out. And you're going to go, okay, whoopee-doo, what do you do there? Well, basically now I say, therefore, my residual is given by my actual value. Well, they told me the actual value was 39.2 years, minus my predicted value, which I've just worked out to be 19.3, which gives me, interestingly, 19.9 years. So I've shown it. And for those 2 marks, you've got to give enough information in there for them to actually be able to say, okay, they've shown me. God, if you thought my tea was cold earlier, yeah, I hate cold tea. All right, have you subscribed to my YouTube channel yet? Again, I keep saying this. Please, if you can, that would be great. Yeah, it just lets me know that you've watched, all right? And that actually there's a purpose to doing these videos. If it's helping you, just click that subscribe button for me. It would be awesome. All right, what's the next one? A random sample of 12 mammals drawn from a population of 62 types of mammals was categorized according to 2 variables. Sorry about the sound of turning paper. Likelihood of attack and exposure of cat. The data is shown. Yep, okay. Use the data to complete the 2-way frequency below. Okay, so likelihood of attack. So the first thing I'm going to do is low and low. So the likelihood of attack is my top one. My exposure is another one. So I want a top one of 1 and a bottom one of 1. And again, what I tend to do is I color them in. So I've got 1, 2, 3, 4. There we go. There's 4 of them there. The reason I color them in, I know what I've got left. So there's 4 there. So what I want now is medium and low. So I want a 2 on the top and a 1 on the bottom. So let's see what we've got. A 2 and I've got a 1. Just 1. So 1 goes there. And now a 3 and 1. So I want 3 on the top and 1 on the bottom. So have we got any with that there? Yep, we do. We've got a 3, 1 there. Anything else? Nope. So that becomes 1 as well. And let's see what we've got here. So we've got 2 and 3. So I'm looking for a 2 on the top and a 3 on the bottom. So I've got 1, 2 of those there. And believe it or not, there's only 1, 2, 3, 4 values left. And there we go, there's your 1 mark. So that's 1 mark for just reading off a table, which we very much enjoyed. And then obviously, when we get to this, it's going to ask me about associations. I just know it's going to ask me about associations. So the following two-way frequency table was formed from the data generated when the entire population of 62 mammals was similarly categorized. How many of these 62 mammals had both a high likelihood of attack and a high exposure to attack? Oh, high and high, right? So let me see. High and high. There we go. Nice and easy. I like that one. It was just 15, right? So 15, how many is mammals? M-A-M-M-A-L-S. Now, a lot of people say, do you need to write mammals? Generally speaking, no, because they've given you a question here. They basically told you how many of the mammals, 15 mammals. Of the mammals that had a medium likelihood of attack, so I tend to always highlight that one there. So the medium, oh, try that one again. So of the mammals who had a medium likelihood of attack, what percentage also had a low exposure? So basically that's that one. So I've got, adding them all that on, there's 4 who've got a medium and only 2 of those. So 2 divided by 4 times by 100, it gives me 50%. Does the information in the table support the contention that the likelihood of attack is associated with exposure? Now, again, yes, you've got to do 2 things here for those 2 marks. 1, answer the question, and 2, use, I mean, it even told you, it says use quoting appropriate percentages. They actually tried to give you a hint with this question, quoting appropriate percentages to nudge you in the right direction. That all of these tables, when you are trying to find association, you percentage by row, not column, by row. So the first thing I did was I added up all the values in each row. There was 41 in that one. There were 4 in that one, and there was 17 in that one. And now what I'm going to do for each of these values is I'm going to do 31 divided by 41, 8 divided by 41, 2 divided by 41. I'm going to turn them into percentages. Now, when I did that, that was 76%, that was 20, and that was 4. We already knew that was 50, that was 0, and that was 50. And then we got 6, 6, and 88. Now, again, you're trying to find, for one of those rows, a set of statistics that's either increasing or decreasing. That's exactly what we're looking for. And as it turned out, this top one here was a beautiful example because it went 76 to 20 to 2. So I'm going to write my response and then we'll talk about it in just a second. Okay, so there we go. So this is the important stuff, all right? So basically, first things first, it's 2 marks. 1, answer the question. There's no point just writing yes, though, and then not doing anything. The examiners aren't going to pay you out a mark for just writing yes or no. You got to qualify it. So when we consider the low likelihood of attack, so what I'm saying here, I'm telling them which row of my data I'm using. We see the exposure, so I'm now mentioning the other thing here because we got likelihood of attack and exposure, decreases. You have to use the word increase or decrease. Goes up, goes down, something. You can't just write the statistics and ignore it. Decreases from 76%. Now, I've not only just said the value of the percentage, I've given the category it is low, to 20%, medium, to 4%, high. All right, so I basically just regurgitated those statistics and put them into a sentence. If you do that, you're going to get the marks. If you don't, sadly, you're not going to get the marks. And there we go. That's the core data done. Woo! Now, thank you very much for joining me, Recursion and Financial Modeling. Have you subscribed to my YouTube channel? I'm sounding like a bit of a broken record. If you can, it's great. It means so much to me. And did you know I've done merchandise for Maths Guru? Why would you want a Maths Guru mug? I have no idea. Like, anyway, but it's there if you would like to on mathsguru.com. Oh, I hate cold tea. Right, recursion and financial modeling. Let's see where we go. Rustling of paper to turn the page of my solutions. Samuel owns a printing machine. The printing machine is depreciated in value by Samuel using flat rate depreciation. The value of the machine in dollars after n years Vn can be modeled by the recurrence relation given by that. By what amount in dollars does the value of the machine decrease in each year? Well, again, we can see this here, that minus value, that's what it's depreciating in. So I'm just going to write there $15,000. Nice mark. Oh, my dollar looks a bit shonky. There we go, $15,000. Nice, beautiful mark to start with. Showing recursive calculations. Again, the number of people, and VK may comment on this all the time, the number of people who do not show the calculations. Not only do you have to show the answers, you have to show the actual calculations. So in here, I'd write V0 is equal to 120,000. Then I say that V1 is equal to, they told you how to find it. They said to get to the next one, you take the previous one and take away 15,000. So all you have to do is write 120,000 minus 15,000, put equals, and then write your answer. So there we go. It's $105,000. And then we repeat it again. Why do we repeat it again? Because it wants after 2 years, which is V2. So we have 105,000, just copying my answer down from previous. I want to minus 15,000 from that. And again, I put that into my calculator, $90,000. Now, again, I'm going to show you one of the things about my calculator. You may see this as a waste of time. I don't want to make a stupid mistake by trying to do something in my head. So here, I'd put 120, 1, 2, 3 in my calculator, and I hit enter. And I know that whenever I see a VN, that is the ANS button on my calculator for a recurrence relationship. That's what I teach my kids. I'm going to go control, minus, there's my answer, and I want to minus 15, 1, 2, 3. Hit enter, there we go, there's my 105,000. I just hit enter again, and it gives me my 90,000. Life becomes so much easier when I'm doing that. Right, what is the annual flat rate percentage of depreciation used by Samuel? Well, flat rate depreciation, I'm going to take the value that it's going down by and its start value. And so in that situation, I'm going to do 15,000 divided by 120,000. And I'm going to times that by 100. And that's going to give me 12.5%. Ka-ching. The value of the machine in dollars after VN is also determined using the form of that. I think this was a huge trick, and that VCAA are doing this a lot recently. A plus BN, and I'm going to make that plus in a moment. Write down the rule for VN. Right, VM. If you've got this in your summary book, is always V0, which in this case is $120,000. All right, then plus or minus B times N. Well, in this situation, it's going to be minus 15,000 times N. And I think the trick here is that a lot of people would have seen that as a plus and gone, well, hold on a moment, I'm sure it's a minus, but okay, VCAA says it's got to be a plus. All right, they're trying to trick you. So 120,000 minus 15,000 N there. Tricky. Amortization tables. I love amortization tables. Samuel has a reducing balance loan. The first 5 lines of the amortization table for Samuel's loan are shown below. Interest is calculated monthly. That's very important to know, right? So we know that each line of that is basically a month. And Samuel makes monthly payments of $1,600. Interest is charged on the loan. That's 3.6% per annum. Okay, so the first thing I'm going to do is I'm going to do 3.6 divided by 12 divided by 100 to tell me what my line interest rate is, right? And that actually works out to be 0.003. I always tend to work that out. I do it as a side calculation simply because it means that it's there for me to use, so I know how to go line to line to line. Use the values in the amortization table, calculate the principal reduction associated with payment number 3. There are so many ways you can work this out, but I tend to know that this minus this gives me this, or I can just find the difference between those two and it will give me that one there. So if I do 318,718.08 and I subtract from that 318,074.23, it gives me the value of $643.85. There we go. So that's just knowing how an amortization table works. Using the values in the amortization table, what does it say? Calculate the balance of the loan after payment number 4. Right, so what does it want me to try and find there? Well, effectively, it wants me to find this value here. Well, to do that, I've got to do 2 things. One, I've got to find out my rate of interest, and that's where my multiplier comes in. Because I know if I take the previous balance and multiply it by my interest rate, it's going to give me this value in here. So let's turn my calculator back on. So let's put that in there. So what have I got here? I've got 318,074.23 times it by 0.003, I think it was. Try that one again. So 0.003 gives me $954.22. So I always tend to write that in. That's $954.22. How do I get this value here? Well, I tend to look at the previous examples just to make sure I don't make a silly mistake, all right? 1,600, 960, smaller value there. Realistically, I have to take those away. So I'm going to take those 2 away. And when I do that on my calculator, I end up with $645.78. And I know that if I do this value here, minus that value there, it's going to give me that value there. And so I'm just going to write that straight into my answer here, which is going to be $317,428 $2,000.45. Ka-ching! Let SN be the balance of Samuel's loan after N months. Write down a recurrence relationship in terms of S0. And again, VCAA, I love doing these questions because so many students don't know how to do a recurrence relationship. So first things first is S0. That's my opening amount from my amortization table, which was 320,000. So 320, 1, 2, 3, comma, S of n plus 1 equals, right, I need my multiplier. Well, that's okay because I already know that my rate of interest, my line interest was 0.003. So I'm just going to add 1 to that. So it becomes 1.003 times S n. And then what was my payment? Minus 1600. And that's where you're going to get your, oh, that's only 1 mark. That's weird, isn't it? Because normally that's worth 2 marks, but in this one, it was only worth 1. Obviously, you've got to use the right letters. Lots of kids every single year use wrong letters. If you can subscribe to my YouTube channel, massive if you can. Sorry to keep asking. I'm going to do it all the way through this video because it means the world to me. It just lets me know that people watch. So very few people watch my videos, and I sort of sit here wondering year on year, why am I doing this? But I do it because every now and again, my subscribers jumps up by like 6 or 7, and then the world goes crazy, or at least I go crazy. So thank you. Rightio, Samuel has reducing... Oh, I've just done that one. Come on, Maths Guru, stick with the program. Rightio. Samuel now invests 500,000 in an annuity from which he receives a regular monthly payment. The balance of the annuity in dollars after N months can be modeled by a recurrence relation of that form. Calculate the balance of the annuity after 2 months if K equals 1.0024. Right, nice, beautiful calculated question. I'm going to put 500, 1, 2, 3, hit enter. And again, it's a recurrence relationship, so anywhere I see AN or VN or PN, I can put my ANS. So I'm now going to do 1.0024 times my ANS, my previous answer. So let's do control minus. And we're going to minus 2, 1, 2, 3. And there we go. What comes out? Calculate balance after 2 months. Oh, that was silly. If I press enter again, is that going to do it? Oh, it did. There you go. I've forgotten I put answer. So at the end of my second month, I'm going to end up by reading that off as 498,398.08. So again, using that functionality in my calculator, I think is a bit of a given. Calculate the annual compound interest rate percentage for this annuity if K equals that. Well, K are the same thing. So I tend to use a formula that says take that value that's in front of it. So in this situation, 1.0024, you minus 1. You times that by 100, and therefore, because to turn it into a percentage, and then you times that by your number of compounding periods, and because it's monthly, I'm going to times that by 12. And again, when I put that into my calculator, out comes 2.88%. Ka-ching. For what value of K would this investment act as a simple perpetuity? I love perpetuities. Perpetuities basically just means that the interest or the money you're taking out of the account is basically created from just the interest. That's your interest. So in this situation, because we've got $2,000 coming out and we want to keep that $2,000 every single time, then I'm going to work out my value is 2,000. I'm going to divide that by my 500,000 because that 500,000 is creating the 2,000 or my rate of interest. I'm going to times that by 100. That gives me 0.4, but the thing of it is I want a value of K. So actually in this situation, I'm not going to times it by 100 because I don't want it as a decimal, a percentage, and that would give me 0.004, and then I want it as my multiplier, so I'm going to add 1 on. So therefore, K would equal to 1.004. Hopefully that all made sense. Okay, so moving on to question number 9. Some time later, Samuel takes out a new reducing balance loan. The interest rate for the loan was 4.1% per annum. Okay, that's going to be important. I know that's going to be important. The balance of the loan after 4 years is this. Now, again, this is a bit of a trick for VCAA because the principal value of a loan can be taken at any start point, right? Okay, 4 years, I know a value. I'm going to count that as my principal value. Here, after 7 years, I've got a final value. So the trick here was knowing where the principal value and final value was. Some will continue to make the same monthly repayment, but they don't tell you what the repayment is going to be. So I think the first thing I'm going to have to do in a minute is find out what his monthly repayment is. He wants to repay the loan fully, so I know at some point later my FV is going to be 0. They're telling me the first 7 years Samuel makes 84 payments, which I already knew because 7 times 12 is 84. Right, so the first thing I'm going to do is fire up my financial solver. So let's go menu, finance, and financial solver. So what do I know? N, well, Okay, N. We'll come back to that. My interest rate was 4.1. My PV, well, I just said my PV was 329. 587.25 because it's a loan he's been given. Oh, money. I like money, so it's positive. Payment I'm trying to find. All right. Final value is going to be minus 280,875.15. 12. There we go. What about my number of payments? Well, we know that actually that principal value and final value were created between years 4 and 7. So 5, 6, 7. So it's 3 years at 12 payments per year. And if I hit enter, I get my PMT as $2,400. Right, so we know what his payment is. Well, to clear the loan, we've got to know what my final value is. I know that to clear the loan, my final value has to equal 0, but for that, I would need to know what my principal value is. Well, how am I going to find my principal value? Oh, hold on a moment. I know what my final value was after 7 years. So I now know that that was created by 5 times 7 or 7 times 12 payments. Yep, everything else. If I now hit enter my principal value, oh, there we go. So that actually works out my principal value, which was 385,895.59. Okay, I want my final value to be 0, so I need to work out what my number of payments were. Oh, 234 payments. So I now know that N was 234. Now it's 2 marks, guys. You've got to give the examiner something to mark. So that was the best I could come up with. Is N my answer? No, because it wanted to know how many more payments was made after the 7 years. So therefore, 234 minus 84 gives me 150 payments. Ka-ching. There we go. That's the end of that one. Now, moving on to matrices. Yay! Okay, have you subscribed to my YouTube channel? All right, I keep asking. I know it's desperate, isn't it? But if you can, it's great. It means the world to me. Yeah, if you don't want to hear from me again, turn notifications off. But just letting me know that you've watched this is massive. Trust me, I am so socially devoid that this is really important to me. An animal sanctuary is run by volunteers and employed conservationists. People volunteer at a sanctuary before they become conservationists. The transition diagram below shows the way in which employees are expected to transition between groups from month to month. Interpret the value on the loop at V. Right, we're going to write my answer and then come back. And there we go. So 80% of those who volunteer, and I think it's important to say 80%, the proportion of those who volunteer from month to month. I've put that there because it was in here. It's a timescale from month to month. Will remain as volunteers. So 80% of those who volunteer from month to month will remain as volunteers. Something along those lines to give VCAA that indication should be okay. All right, let's move up. Write the transition matrix T that represents the transition matrix diagram above. Well, that's nice and easy. Let's bring it back down. So there we go. Let's do that. I'm going to write V and C there, making sure I write V and C there. So V to V is 0.8. The column must add to 1, so that gives me that. C to V is 0. And there we go. That's my transition diagram my transition matrix. And according to the transition diagram, what is expected to happen to each group of workers in the long term? Again, they want you to write a sentence for this. And this is pretty much what I think would come up out of it. All people who volunteer will become conservationists, and those who are conservationists will remain as conservationists. I want to tell people, well, I know what's going to happen. My volunteers are going to become conservationists. Eventually, all of them will, and those who are conservationists will remain as conservationists, right? Again, 1 mark, making sure that you tell the examiner as much as you possibly can. Now, moving on to question number 11. Of course, storming through this. The sanctuary is trying to increase the population of an endangered fish during this process. Okay, there's some information there, not going to read it. From year to year, changes to this fish population can be modeled by the recurrence relationship given there. Okie dokie. We've got our transition matrix and we have our initial state matrix here. Now, it's really important to know how matrices are multiplied together to complete the following multiplication for the row that determines the number of adult fish. If I look at this one here, it is the 3rd row. So that multiplied by this will give me my adult fish. So I've got to be given 0. So 0 times 10,000. So the first value here times the first value here. The second value here is 0.25, which will multiply by my 1,000. That must be 0.5. And the next one will just be 0. So reading off that rows and columns is really, really important. Okay, what do we got next? To take into account the new eggs added to the population where the adult fish begin to breed, the following matrix recurrence is used. The extra number of eggs expected to be laid by the adult fish each year is represented by K. Now, I do this slightly differently than I think most people do, because If R1 is that, show that K is 500. Now, in a closed system, and by that I mean there's no B, the numbers of fish do not change. The numbers of anything would not change. So what I would have is that if I added all those together, which I will do in just a moment, in fact, I'm going to add those all together now, I get 12,300. In a closed system where I'm not adding and taking away, every single one of my R1, R2, R3, R4, and R5 will add up to 12,300. It has to, because no fish are coming and no fish are losing. When we start adding things into my system, well, that's only going to come from one place. And what I did was I then, well, hold on a moment. If I now add all those together, what I actually get, he says, looking at my working out, is 11. Try that one again. When I add all these together, my apologies, that actually came to 11800. When I add all those together, it gave me 12300. So the way I explained that was I said, well, the total from R0 was equal to 11800. The total from R1 was equal to 12300. Therefore, K would be equal to 12300 minus 11800, which equals 500. And I know that lots of people do it in different ways. To me, I've seen this type of question over and over again, and I just like the simplicity of the idea of, well, let's just add them up, add all those numbers together, and work out what the K is. Determine how many adult fish there are expected to be after 2 years. All right, well, this is a calculator question. So let's crash out of that for the moment, and let's see what we can come up with. So what I'm going to do is I'm going to put T into my financial solver. Sorry about the banging. T becomes equal to, just a quicker way of doing this, what I want, a 4x4. Hit the wrong button, hit the screen and not the calculator. So there we go, 4 tab 4. And what values drawn in there? 0, 0, 0, 0, 0 0.4, 0.25, 0.50, 0 0.6, 0 0.75, 0 0.5, and 1. There we go, that's my T. So I'm going to do B becomes equal to, and let's put another matrix in here, and we'll make that a 4x1. So B was equal to 500, we said 0, 0, 0. And then we got R0 becomes equal to, and let's put in another 4x1. Now I put in R0 for a reason, 10,000, 1,000, he says, 800 and 0. There we go. So I'm now going to say, well, there's my R0. So R0, put that into my registry. And what do I want now to do? I want to do T times my answer. And I want to plus my value of B. Now, the reason I'm doing this is just to check that I've got that right. And you can see that my R1 has come out. So here we go. Here is my R2. So what I'm going to do is I'm going to write that down as 500, 200, 1,325, 10775. And what have we got here? So therefore, my adult fish, he says, was 1,325 adult fish. And the reason being is that's the third row. Yeah, if you remember, the third row here is adult, so the third number here would be adult as well. Now, love this question. Which populations, A, B, A, and D, remain the same in the long term? Now, what lots of people tend to do with this question is go, well, I'm just going to raise T to a high power and multiply. Well, that's not going to work here anyway. So what I want you to do is notice that I'm just going to keep hitting enter on my calculator. And lots of people may go, oh, it's just going to be the first two there, which would be E and B. Because you notice the 500 and the 200. But what notice, yeah, that 100 is getting smaller and smaller and smaller and smaller and smaller and smaller and smaller until suddenly, after a certain number of transitions, what do we notice? That bottom number is getting bigger and bigger and bigger, and will keep getting bigger and bigger. There's nothing stopping that getting bigger. But my first three are actually staying the same. So in this situation, I would say that E, B, and A will stay the same in the long term. What have we got here? Oh, Leslie Matrices. Now, obviously, this is brand new to the course. I have to say, I really don't like the last part of this question. I don't think it's been written particularly well. But let's not split hairs about that at the moment because there are many hairs to split. So the sanctuary monitors the breeding patterns of the female population of a species of marsupial on a nearby island. All right, so reading the rest of the context of the question, we know we've got our Leslie matrix. Thank you very much. We've got our little transition diagram, I think it is. The following table shows the birth rate for each of the 4 age groups, the average proportion of offspring born to each age group, and the survival rate. Some values are missing on the table. All right, so birth rates. If we remember, our birth rates are the values that go backwards. All right, so we've got 1.4. We got 1.6, right? So 1.4, that's got to be 1.6. And the birth rate of the first age group is always going to be 0 because we don't feed them back in. Yeah, so that's my birth rate. What's my survival rate? Well, my survival rates are the ones that go this way. And so what do we have here? Well, we have 0.5, 0.5, and 0.2. I quite like that. A nice introductory question. Thanks very much. Ease me into it. All right, here we go. Next part of the question. Have you subscribed to my YouTube channel? I know I'm like a broken record and it's so annoying. But again, that one click means so much. And sitting here on my own, it's late at night at the moment, trying to record these videos. I lose faith, really. Sometimes I go, yeah, there's no point in doing this. And then suddenly I get like 6 people subscribe and I get really, really happy. So thanks very much for doing that if you can. Greatly appreciated. Right, by calculating S1, determine how many marsupials there are aged 0 to 3 years after 1 3-year period. All right, so again, what I tend to do is close this down. Nope. I mean, there's lots of ways of doing it. You can actually open different things, I have found out. But what I'm going to do is going to put L colon equals, I'm going to do a 4x4. You're going to let me select that? Apparently not. There we go. So 4x4. And let's put my 0, 1.4, 1.6, 0, 0.5, 0, 0, 0, 0, 0.5, 0, 0, 0, 0, 0.2, oops, and 0. And for some reason, my L went missing from the beginning of that. So let's do that again. L becomes equal to, there we go. And I'm going to put S0 becomes equal to, and let's do that. And we'll do a 4x1 if you'll be so kind. And I've got 20, 40, 50, and 15. There we go. So S0, hit that one in there. I want to do L times my answer. Hit that, and out comes after 1 3-year period, that one there. So again, I tend to write this in as 1, 3, 6, 10, 20, and 10. So therefore, 136 marsupials. Hoping you spelled that correct. Right, now this is the part of the question I do not think was particularly well written. What percentage of this female marsupial population are aged 9 to 12 years after the second 3-year time period? All right, so what percentage of this female marsupial population are aged 9 to 12 after? Now, when it said this, as far as I was concerned, I'm saying, oh, well, it's this one here. So I've got, how many people I've got there? Well, basically, I've got 136, 46, 56, 66, 176. So I have 176 marsupials at the moment. And I know the only people who are going to go from into the 9 to 12 group are this percentage here. So I've got 20 people at the moment. After one rotation, I've got to work out what happens to those. And we know from our transition matrix, yes, that 20% of them, if I've got this 0.6, sorry, 6 to 9, 20% of them live to 9 to 12. So I said, well, okay then, I've got 0.2, 20% of those 20, which gives me 400 on 176, which gives me 2.3%. Now, that's what I think is the answer, but it depends how you interpret the question, because it could go, well, hold on a moment, what if I actually do my matrix again? What if I get my third rotation, yes, and say, well, in which case that still becomes 0.2 times 20, but now my totals are 46 plus 68 plus 5 plus 4, which is 123, which when you do that, gives you 3.3%. So I don't fully understand what the interpretation of the question is supposed to be, because it says what percentage of this female marsupial proportion, and as far as I'm concerned, I just worked that out, so I was counting that as this. I'll leave it to you to interpret. I don't know if VCAA will ever come back with the solutions to this. Okay, the next one. 4 cleaners at the sanctuary. Trish, Kobe, Sam, and Mom take turns cleaning 4 different areas, A, B, C, and D. The cleaning roster for 4 weeks in February is shown in the table below. The information from this table for week 1 is presented in matrix N, when N is multiplied by the permutation matrix. So for that to happen, we have to have N as A, B, C, D, and we have our permutation matrix there. Okay, And that's going to give me my answer of, what did it say? Clean roster change from week 1 to week 2. So we're looking to see what happens to get that to change to B, C, D, A. Now, again, there are lots of ways of doing this, but what I'm saying is this A has moved to my last position here. All right, so basically, I've got to have it that, where's that going to go? Well, let's start with B. B is here, all right? It's moved to my first, and here it's my second. So I basically want that to be a 1 there. I want it to be in my second position down. So that's to be 0, 0, 0, 0. All right, that's got to be there. What about my next one? C has got to be second. Well, at the moment, it's in my third, and I've got to move it to my second. So I'm going to put that where? B is my second. It was my third. So so that column there has got to be 0, 0, 1, 0, I think. No. All right, so when I tend to do this, I try and work out whether I've got a from and to. So for this particular diagram, what I said, well, let's have it from and to. So I've got positions 1, 2, 3, and 4 to 1, 2, 3, and 4. So I want A to move from position 1 to position 4. So to do that, from position 1 to position 4, I need a 1 here. So that's going to be 0, 0, 0, and 0, 0, 0. If I look at B, I want it to move from position 2 to position 1. So from 2 to 1, that's got to be a 1 there. C, I've got to move it from 3 to 2. So from 3 to 2, I've got to have a 1 here, which means I've got to have a 1 there. So as far as I'm concerned, that there would be my correct transition matrix, right? There may be other ways of doing it, but that's what I did. The transpose of the permutation matrix PT was used to create a new roster for March. The table below shows the clean roster for March. Some values in the table are missing. Complete the cleaning roster. Right, what I did here, he said, rustling paper again. My goodness, talk about unprofessional. So what I did here was I actually put in P. So I said, well, okay, here's my P becomes equal to, let's put in a 4x4 matrix. 4x4, if you will. No, not 4x43. It would be here all day. 4x4 is so 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. There we go. So there's my P. And what I want to do now is work out, well, how do I change this around? So I was like, well, let's put in another matrix. Let's call it N. So N became equal to, and this time I want a 1x4. So 1x4, because otherwise it's not going to multiply properly. I've got A, B, C, and D in there. There we go. So if I now do N, and I want to now do answer times P, and I want to do the transpose of that. So matrix and vector transpose, and there we go. Nope, that didn't quite work. So what have I got to do here? Because I did N times PT. I'm a muppet. So let's just do that again and actually put colon equals. Thank you very much. If we go there now, there we go. So what do I get? So, oh my goodness, come on, people. So right, let's do N, and we do answer times P transpose. Guys, it's really late at the moment. I am so sorry. Let's try that one again. 1, 2, 3. There we go. So my next row there would be D, A, B, C. My one after that would be C, D, A, B, and then B, C, D, A. Other than making a complete meal of that question, hopefully that made sense if I was using my ANS the right button. Oh my goodness. Rightio, networks and decision mathematics. Yay. All right. Have you subscribed? Can you subscribe to my YouTube channel, please? It means the world to me. The Sunny Coast Cricket Club has 5 new players joined its team A, B, C, D, and E. Right, the graph below shows the players who have played cricket together before joining the team. For example, the edge between Alex and Bo shows they've previously played cricket. How many of these players had Emerson play cricket with before joining the team? Well, let's look at Emerson. How many connections does Emerson have? Well, it appears it's just 1. So in which case I would write here 1 player. Nice, easy questions to start everyone off. Who had played cricket with both Alex and Bo before joining the club? So Alex is here and Bo is here. So let's see who's got a connection between Alex and Bo. Dale, perfect. But there also happens to be Cameron as well. So in that situation, we would say Dale and Cameron. All right, nice, simple networks question to start with. A cricket team has 11 players in a batting position. All right, 3 of the new players, Alex, Bo and Cameron, can bat in positions 1, 2 or 3. The table below shows the average scores in runs. Now, the trick to this question was everyone thinks, oh, it's a Hungarian algorithm because it's set out like a Hungarian algorithm. But the trick to the question was here, it wanted to maximize the team score. So in which case, it was actually a lot easier than it looked. Why? Because, well, if we look at bat in position 1, who is it obvious that you're going to have? Well, you're going to have Bo in batting position number 1 because he scored the most runs in batting position 1. All right, well, Bo's now been taken. So who would you have in batting position 2? Well, hopefully Cameron would be in batting position number 2 and leaves Alex in batting position number 3. So a lot of people would have gone off and gone, oh, it's Hungarian algorithm. No, it isn't. Rightio. I've seen this question before and I hated it then. But anyway, local fitness park has 10 exercise stations, M to V. The edges on the graph below represent the tracks between the exercise stations. The numbers on the edge represent the lengths in each track. Right. What is the shortest distance in kilometers covered in training program 1? Now, again, I don't know that there is an easy way to do this. Yes? What is the shortest distance in kilometers covered in training program number 1? Team must run to exercise O. You could do Dijkstra's. Could you do the Dijkstra's on this one? What does Dijkstra's find? The shortest path? You could do. I think, but I didn't. I just basically went, well, okay, here's a path, add it up. 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 I just did it the long way. It just seemed quicker. I mean, it might not have been, but ultimately when you did it that way, the shortest path actually went from S to T to U to V and then to O, right? So there may have been other ways to do this. Dijkstra's maybe, I'm not really sure. My mind is telling me, no. But anyway, so in that situation, when you did that, you got 3.2 kilometers. And maybe one day when I've got literally nothing else to do, never going to happen, I'll actually try that. Which exercise station would training program 2 finish? The team must run along all the tracks just once. Okay, well, in that situation, I've got something to do with Euler. My brain is going, Euler. And so what I'm going to do is I'm actually going to do all the degrees of each vertex, and that's 3, 2, 4, 3, 2, 4, 4, 4, and 2. And what do I notice? Oh, I've only got 2 odd vertices. So there we go. So I've got 2 odd vertices. I know that it's going to start at one of those and it will end up at the other one. So in which case it is going to be P. Right, the next one here, to complete training program 3. What is training program 3? The team must visit each exercise station and return to exercise station S. All right, the team must visit each exercise station and return to exercise station S. So you've got Hamiltonian. All right, to complete training program 3 in the minimum distance, 1 track will need to be repeated. Complete the following sentence by filling in the boxes below. This track is between exercise stations. Right, so I've got to go what? Between 3. The team must visit each exercise station and return to S in the minimum distance. All right, so let me think what the minimum distance would be. So first things first, 0.6. 1.2, 0.8, 0.8, 0.4, 0.8, 0.9, 0.7. So basically you can work your way around, and I'm going to fudge this one a little bit, guys, because if I'm brutally honest with you, when I saw this one before, I wasn't overly sure how to do this one. And if you've got a great way of doing it, let me know in the comments below. This is the one part of this whole exam where I'm like, I still hate this question. All right. The right answer, as far as I'm concerned, is between T and S. I know that because I remember the question before. All right. And I seem to have a photographic memory for questions I absolutely hate. Between T and S. If I can at some point later on and I go, oh, that was so stupid, I'll do an update to this video. But let's just take it at the moment that T and S. And if you know how to do that, you're a better man than me. Right. Question number 17. We're heading towards the end of this. Thank you very much for watching so far. If you can subscribe to my YouTube channel, that'd be amazing. And obviously there's mathsguru.com for summary notes to download. Probably a bit late by the time you've watched this, but anyway. Question 17. Training program 1 has a cricket team starting from exercise station S and running to exercise station O. I'm just going to highlight that from S to O. For safety reasons, the cricket coach has placed a restriction on the number of people who can use the tracks in a fitness park. The directed graph below shows the capacity of the tracks, right? When considering the possible flow of people through this network, many different cuts can be made. Determine the capacity of cut 1. So for a cut to be included, it's got to go from left to right across. Yes, that is. Yes, that is. And yes, that one is as well. So basically 20, 12. So it's 20 plus 12 plus 20 gives me 52 people. Right, what is the maximum flow? I love these questions. So the maximum flow, as far as I'm concerned, let's keep those coloured in. What I can now do is I'm going to go across each path and I'm going to find the maximum flow through each path and then work out. So if I look at this one here, I've got 20 and 22. So the maximum I can get through those 20. So I'm going to write 20 here. That becomes 0 and I have a capacity of 2 there, right? Because you never know, I might be able to try and squeeze stuff through M&O, but it's actually not going to happen. Next one I'm going to look at is this one here. All right, so what have I got? I've got 12, 10, 10, and 12. So maximum I can get through there is 10. So that's got a capacity of 2 now. That's become 0, that's become 0, and that's become 2. Lovely. Okay, now if I look at this already, I can see that there's now no way anything's going to get through there because of that 0, and there's now no way of anything's going to get through there either. So the only way I've got to go now is here, so I'm just going to do the bottom. And what I've got here, 25, 20, 10, and 10. So again, I'm going to do another 10 here because that's going to become 15. That's going to become 10. That's going to become 0, and that's going to become 0. So now I've pretty much blocked off anything going that way. So let me see where I can go now. So I've got a 15, a 10, a 15, a 5, and a 12. So what I've got here, so I've got a 5. That's my limit there. So I'm going to knock 5 off of each, or is there another way I can do this? Oh no, actually let's do this way here. That might actually make more sense because again, I've got 12, 15, 10, and 15. So I can knock 10 again. So there's 10, so that becomes 5. That becomes 0, that becomes 5, and that becomes 2. And actually, if we look at this now, right, that's now cut off, that's now cut off, this is now cut off. So basically, there is no way of getting water anywhere else in that network. So I think pretty much I've got my maximum flow. And when I add my 10, 10, 10, and 10 together, 20, 30, 40, 50, I get my maximum flow of 50 people. All right, I love that algorithm, brand new this year that I found out. Beautiful. Right, let's turn that calculator off for a moment because I don't actually think I need it. Right, here we go. So this one required us to draw a diagram, and I'm just going to pull my diagram into place because I couldn't think of doing it in any other way. The Sunny Coast cricket team, Coast Cricket Club Rooms and Oval are undergoing a major works project. This project involves 9 activities, A to I. The table below shows the earliest start time and duration in months for each activity. The immediate predecessor is shown. Is missing. Right, complete the following sentence by filling in the box. The dummy activity could be drawn, right, again. For here, what I had to do was I say, right, I know that here, A and B have a 0 EST, so they basically come off my beginning. So there's my A, and there's my B, right? So there's A, and there's B. I'll come back to that in a moment. What do we have? C, immediate predecessor was A and B. So there we go, there is my C. So in which case, before I go any further, I now know that my dummy network would have to be from the end of B to the beginning of C. So end of B to the beginning of C. It's no other way it's going to be able to do it because it just doesn't work otherwise. Right, where do we go next? So that's my C is done. Right, D, C, D's immediate predecessor is C. So D's immediate predecessor is C. So I'm going to write, oh, I'm not going to do that here. All right, so there's my D. What have I got next? So D is done. E's immediate predecessor is also C. All right, and I'm actually just going to do this. You'll see why in a minute. F's immediate predecessor is B. All right, so F's immediate predecessor is B, and I'm going to do that. What have I got next? G's immediate predecessor is D. So G's immediate predecessor is D. Now I'm actually just going to draw that in here again. You'll see why in a moment. There's G. H is immediate predecessor is F. So there's my H. And I comes off of here. So that was my diagram for this particular network. All right, so there we go. Now, what is the duration in months of activity C? Well, again, I'm going to try and do is zoom in. And I'm going to put all these annoying boxes on it. Can I change color? Let's do pink. All right, so I've got do. Now, I always do my boxes on the edges. It just makes a lot more sense. I never used to. I used to do it on the vertices, but then I could never get the float times. It was so annoying. All right, and then we've got one at the end there. Thanks, VCAA, for letting me run out of room. Now, I know you can't see it at this moment in time, but I'm going to put in my earliest start times from my table. So my earliest start time of A was 0, earliest start time of B was 0, earliest start time of C was 5, earliest start time of D was 7, earliest start time of E was 7, earliest start time of F was 5, G was 14, H is 8, and I was 18, and then we just need to put in our values of durations. So A is 2, B was 5, we don't know what C was, D is 7, E was 9, F was 3, G was 4, H was 9, I was 2. Okie dokie. So let me see. Well, basically, I can now work out what the earliest start time of C was. Or the duration of C was, because C's early start time was 5. D's earliest start time was 7. It's got to be 2. All right. So C has automatically got to be 2. So I'm going to put a 2 in here. And let's just scroll up and say, what is the duration? It is 2 months. Ka-ching. Thank you very much. Right. The next part of the question says, name the 4 activities that have a float time of at least 1 month. So we're going to go back to this. Let's zoom back in again a little bit more. Right. What I'm going to do is now finish my forward scanning, because 18 plus 2 is 20. So that's going to be 20. I'm now going to backward scan. All right. And I love backward scanning, because what I do is this value here minus 2 gives me that value there. So that value minus the I gives me the 2, gives me the 18. Thank you very much. All of these are spanning off of I. So they're all going to have an 18 minus 4, 18 minus 9, 18 minus 9. So in which case that's going to give me 9 there, 9 there, and 18 minus 4 gives me 14. And I'm happy there's a 14 there because it's on my critical path. Okay, so G has a latest start time of 14. D has a length of 7. So 14 minus 7 gives me 7. We got that one there. Okay, now I've got a choice coming in at this module here, because I've got D and E coming in. Well, D's latest is 7. E's latest is 9. You use the smallest, so it becomes 7. 7 minus 2 gives me the 5. We like that. All right, so let me see. What have we got here? Let's go the other way now. We've got H is 9, minus 3 gives me 6. He says drawing on that wasn't quite what I meant to do. So 9 minus the 3 gives me 6. So that's going to be 6. Right, what have we got here? So let's draw my arrows on there and there and there and there. I thought I'd missed one. Yep. All right, so what have I got here? So I've got a choice coming in this way. So this is a node. I've got one backing in here and one backing in here. So I've got a choice of 5 or 6. So let me see, 5 or 6, which is the smallest? It's 5. So 5 minus 5 is 0. And in this situation going along here, I'd have 5 minus 2, which gives me 3. Right, so just checking that's all right. It is, and I want a float time, a minimal float time of at least 1. What did it say? Name the 4 activities with a float time of at least 1 month. Well, there has got a float time of 1 month. That's got a float time. That's got a float time. And that's got a float time. And I think all the rest are the same. So A, E, F, and H. So let's go back to here for a moment. So A, E, F, and H. Right. The project, or don't we just love crashing? Well, I actually quite like crashing now because it's all a bit formulaic. Right. The project is to be crashed by reducing the completion time of only 1 activity only. What is the minimum time in months in which the project can be completed? The first thing I did was I actually worked through all the different paths. So I went, okay, so let's look at there's one path. Here is another path. Here is another path. Here is a path. and here is a path. All right, so I went through all the different paths and list them out. So I'm going to use this sort of last piece of VCAA's paper to say, right, there was a path through A, C, D, G, and I, A, C, E, and I, B, F, H, and I, B, C, D, G, and I, and then B, C, E, and I. Right, now what do? I write all the lengths on there. So A was 2, 2, B was 5, 5, and 5, C was 2, D was 7, E was 9, F was 3, G was 4, H is 9, and I was 2. So now working my way through all of those paths, when I added all those together, I got that this path took 17, this took 15, 19, 20, and 18. So the whole point of this is that's my critical path, all right? So B, C, D, G, and I is my critical path. So the question is there anything on my critical path that I can reduce? Yes. Well, as it turns out, I've got two things I can reduce. I've got B, yeah, and I. Now, what I'm saying here is by reducing B here, yes, I'm also going to end up reducing B here. So I can take B down by 1. And if I take B down by 1, yeah, that's going to make that 18, 19, and 17. All right. Well, 19 is still my critical path, so I can take B down again. I could theoretically take I down, but the reason I'm not going to take I down is because I will just reduce everything, all right? And it's already told me I can only reduce one activity. So I'm going to keep going with B for a moment. Let's take B down by another one. That's going to give me 17, 18, and 16, all right? I've still got capacity because I've still got 18. I can still reduce B by another one, and that's going to give me 16, 17, and 15. Now, the problem is I can reduce B by another one, but then basically this will become my new critical path. There's actually no point reducing anything on here at the moment unless I could also reduce it on here. And because I've chosen B, there's not much else I can do. So actually the correct answer here is that B can be reduced by 3. And so my new minimum completion time, which is what the question actually is asking, is 17 months. Again, these questions are designed to take some time, all right? So don't worry if you're sitting there thinking, oh my God, I'm going to run out of time. Hopefully you won't, because you'll have smashed all the others. But I'm done. Thank you very much for watching. Hopefully this has been useful. There is a paper 1 coming, but I'm probably not going to make it in time for the VCAA exam tomorrow. But if you're watching this next year or the year, whatever, hopefully the paper 1 is useful as well. Please subscribe to my YouTube channel if you can. Merchandise is available on mathsguru.com. This hoodie, for example, nice little hoodie with a little Maths Guru. Anyway, I'm done. Thank you very much. Take care. Good luck for whatever exams you're preparing for, and hopefully I'll see you again soon. Bye-bye.